Welcome back to session 13 of Java Full Stack Made Easy. Hope you are enjoying the series. Let's get back to what we were doing in the previous session. So we discussed about the packages, we discussed about the import statements, we discussed the best practice about the import statement, that is including the classes that we want to import, not the entire package. That means we should not be writing star, instead we should be writing the class names. Okay, so this was about the packages and import statements. So let's go ahead in this session. As I told you, we will also be talking about the access modifier. So access specifier is something that we have already discussed in the previous session. So I told you that we will be talking about the access modifier. So obviously one access modifier we have already discussed, that is about the static keyword. So there are more access specifiers that can be used with the functions. That is, final is one such access specifier, abstract is one, then native can be applied. So as the time progresses, we will be talking about those access specifiers. Before that, we will cover up the concepts of classes and objects. And if you remember, I told you about one-liners in Java and creating objects in a traditional way. So we will see that and we'll move ahead, and also we will be talking about the concept of overloading today. Okay, and yes, one of the shorts I have created on overloading versus overriding. So if you want to also go through with the interview questions, you can go through with the shorts that I have already posted into my YouTube channel. So let me create a class as for now. Let's call it as demo2 or something. Let's call it as demo classes, or let's just call it as demo Java. Okay, I can include a main method if I wish to. There we go. Now in this demo Java, what I will do is I'll be creating functions, right? So we have already seen the advantages of using functions, because if we organize the classes into functions, smaller parts, then it can be reused. We can pass in the arguments to it, then we can reuse it wherever we want it, right? So obviously whenever we are building an application, it has to be divided into smaller parts so that it will be easy for us to modify them. Now let's go ahead and create a function. Let's create some variables here. So I'll be creating a variable. Let's call it as int age of the user and then string name of the user. So two variables I'm creating here, int age and string name. And then I will be creating a void init method. This method I'm creating to initialize the data members of a class. That is, age equals to, I'll be giving some age, maybe 19, and then name equals to, I'll maybe give it as Virat, right? So let's save it, and see, each method is written for its functionality, right? So whatever functionality we want to include, based on that itself we create functions. So one method is completely dedicated for initializing the value of a variable. Then I'll go for void display method, and this will be used just to display the value of the variables that are initialized into init method. So I'll print age, and then system.out.println, I'll also print the name of the user. So very simple and straightforward code I have written. There are two functions. One function initializes the data members of a class, and then another function just prints it. So let's go with both the approach that I used in the previous examples, right? So the traditional way of creating object is like this: demo Java d is equal to new demo Java, and then obviously the best way of creating this object would be demo Java itself. So d dot, I will call the init method that initializes the values, and then d dot display method that will display the values, right? So I will save this and try to run this piece of code and see what would be the result of this. So when I run this, you notice that this will give me 19 and Virat. So display method is working fine, and also init method is working fine. Init method is initializing the value, whereas display method is displaying us the value. Looks good, no problem whatsoever, right? So this is fine. Now what I want is, I want to maybe initialize this value from the users, right? So now I want to initialize the values, but user should provide me the values. So one method I want where this initialization should happen automatically, another method I want where the initialization should be taken from the user. So at that time, what will I do? So I have to overload this method. So when I'm initializing this, so obviously I have to take what? Int age again, comma, string name. So as for now, what I will do is I'll call it as age var and then name var. Okay, so let's save this because I don't want to conflict between the names of the methods. If functions perform closely related task, we tend to give it the same name. So because it is performing the same task itself, both the methods are initializing the values of the variable. Only difference is that this method is initializing the value directly here, and this method is initializing the value taking it from the variables like age var, right? And then whatever name is given, so a name var should be taken like this. So let's save it and now understand how things work here. So I am creating the object of this demo and calling init method and display method. So it is initializing the default values whichever I have given, and then it works fine like this. Okay. Similarly, if I create another object of this demo, or with the same object, if I call d dot initialize method now with two arguments, that is age, let's say 45, and then I will give the name, let's say Rohit, and then I would like to call d dot display. So after calling this d dot display after the init method, now you notice the second result is 45 and Rohit. So whatever values I have given here, those values are initialized to these variables here, right? So the main agenda of showing you this particular code is that here I am trying to overload the methods. So method overloading means providing the name, providing the same name to the functions with different function signature. So this concept is called as function overloading. Okay, let me first copy this and we will also see a lot of things into this. And one more important point for you is that assignments for string buffer and string builder is already added into the assignment sections. So I hope you have already gone through with the array assignments. Now the assignments related to string buffer and string builder. Obviously, once again, when you are working with string buffer and builder, at that time also you should be using loops and arrays, right? So loops and arrays is a very basic concept which will be used in any logical question. So this is our session 13. So I'll create a day 13 as a repository. So let's create a day 13 repository / demo1 overloading. So I'm trying to perform an overloading. I'm trying to overload a function. So let's commit this. Everything looks good and overloading has happened. And what I will do now is I'll make it pretty simple and straightforward. And also before I go to the other concept and rules and everything about the overloading, I'll show you one more important thing here. That is if suppose I'm creating things like this. Demo Java, okay, and d1 equals to new demo Java, and then I call d1 dot display function. So I want you to predict the output of this d1 dot display. Suppose if I don't have this method at all, so what would be the result of this? Okay, a display method is called, right? So now let's see whether it is going to print us 19 and Virat or not. Okay, the first one obviously prints that because we have already seen it. Second one we have to check here, right? So I'll save this piece of code and run it and check what is the result. So when I try and check the result, you can notice that it is giving me the default values of the variables. Age variable, since it is integer, default value is 0, and the name variable, which is a string, all class types are null by default, so that's why it is giving me the result as null, right? So what does this mean? If you remember, in previous sessions I have already spoken about something called as instance variable maintaining the separate copy for each of the object. So object D is different, right, and D1 is different. So whenever you are initializing the variables, at that time you should make sure that the initialization happens before the display function. That is why we are not getting the result here. So for D the values are initialized, but for D1 the values are not initialized. You can notice that I have not called a init method here. Even if I call a init method after calling the display method, at that time also there is a problem here. Now what is the problem? The problem is that display is displaying the values first and then it is initializing. So it is displaying the default values after that initialization has happened. If you print it after this, then obviously you will get the result. That's because initialization has happened here. So initialization is a very important aspect of programming. So initialization should be something that has to happen at the beginning, very beginning, right? So let me put this particular piece of code into the repository. I'll go back to overloading and I'll show you a few more examples on overloading, rules of overloading and everything. But because we have come down to this concept of creating objects and creating classes and then calling that init method, so let me focus on that first and then we will go back to the concept of overloading. So here is demo 2, a problem statement. What is the problem statement? Init method has to be called before display method to display the actual values of the variable to avoid the default values. So the solution for this is that instead of creating an init method, what you need to do is you just create a function same as the class name demo Java and you don't give a return type to it, and this itself is called as the constructor. Okay, a constructor is a special method which has same name as the class name, and this is used to initialize the data members of a class. Now you notice, since there is no init method, I create the object D, I create the object D1, and I'm not calling anything. I'm just calling display here, I'm just calling display here. Now for both the objects, the value will be initialized for sure. So you can see that the values are initialized. So the advantage of constructor is that constructor is the first thing to be executed in a program. Okay, here itself you are calling the constructor. That is why if you call just the display, still it is being called first. So you can see that class names here a method is being called which has same name as the class name. So there are two uses of a constructor. One is to initialize data members of a class. Second one is to create object of a class. So constructor is used for two purposes. One is to initialize the data members of a class. Second is to create the object of a class. So in the previous program we had a problem, that is init has to be called before display method. So because of that we have replaced that init method and created a constructor itself. So because we have created a constructor, constructor is the first thing to be called in a Java class. So while creating an object, so whenever we are creating an object, constructor will be called, and these functions cannot be called without constructor. So obviously all the values will be initialized for you. So let me copy this and put this into the repository as a solution. Okay, demo 3, solution, constructor. I hope the use of constructor is pretty much clear to you, that is to initialize the data members of a class, and because it is the first thing to be called in a program, so we need not worry about calling a constructor. Okay, and now one more point, that one liner which I showed you, let me also show you an example about the one liner. So what one liners can bring into us. See, this init method I created before, and I have shown you how init method and display method works here and here as well. So what I will do is I'll write one liner now. So what is that one liner? So if you remember, I have created something like this, demo.java. So I'm calling an init method. Again I'll go for new demo.java and then I'll call the display method. Okay, so now once again you predict the output of this particular piece of code. Okay, so now you might see that there is something called as init being called and then display is called. So if init is called before display, then it has to initialize the value of the variables. Now let us see whether it has initialized the value of the variables or not. So when I run this piece of code, you will notice that the values of the variables are not initialized. Now why is this? Again there is a problem here. So let us understand what is this problem now and what is the solution for such problems and where we should not use the one liners. So this is my demo 4. Again, problem statement. So how do I avoid such type of problems, and why is this problem being raised first? What is the problem here? Okay, so even if suppose I replace this, let's in the previous example I showed you that if you replace that with a demo.java, that is a constructor, it will initialize the values, and you don't need to actually call this what init method, constructor will automatically be called. So I am calling a constructor here, then I am calling a display method. Now let's see what happens first. Okay, when I call it, so it is initializing the value of a variable, so constructor is working perfectly fine here, right? But what if it was just a init method, and why it is not actually giving me the result when I am initializing it into a init method, although the init method is called before the display method itself. So this two lines that I have written, it is same as writing this. So demo.java d1 is equal to new demo.java, and then d1.init is being called. Then I will create another object demo.java d2 is equal to new demo.java, and then I will call d2.display. So what happens is, see, on this line what I am initializing is I am initializing the value for d1. So d1 dot age and d1 dot name will be initialized, whereas for d2 I am not calling an init method, so d2 dot age and d2 dot name will not be initialized. So because of that, this will be default values itself, right? So let's see what is there in d2 now. So d2 is again 0 and null. So writing these two lines is same as writing these four lines itself. So that means whenever you are using one liners, at that time you don't have an object reference here. Because there is no object reference, every time you write this new demo.java, it means that you are referring to a entirely new object. So because you are referring to an entirely new object, that is why these values are not initialized. That's why if you remember in the previous sessions, I told you that you use the one liner only if there is no reusability, or only if you don't need any object reference in future. Okay, if you don't need the object reference, then only you are going to use it, else you might encounter problems like this. That means every one liner creates a new object for. Okay, and we know that every object contains the separate copy of member variables. Okay, so for this problem statement, again, it's not a solution, it's just the insight of the problem, why that problem has raised. So demo 5, why the problem. Okay, so then the next part is again the solution. The solution is what? Give the constructor, you will get the solution, even if you write a one liner here. And if it is a constructor, multiple times the constructor is being called. For both the objects, this constructor will be called demo.java, and then you get the result. So this is the solution for that. You don't need an init method, you just call the display method, one object will be created, you call the new demo.java, two display methods, two objects will be created. One display method will be called on this particular object, and this object only constructor is called, nothing else is called there. So let's save it and run it and check. So here is the solution. Now to prove you that there are two objects that are separately created, what I'll do is I'll just add a system.out.println constructor. So every time an object is created, constructor will be called. So when I run this, you notice that constructor is called twice. So this again proves you that there are two objects being created. So anytime you use a one liner, at that time an object is used, object is created. So whenever you do this new demo.java, a new object is created. For this also a new object is created. So I hope the concept is clear, the problem statement, why the problem has occurred, and what is the solution for that. So always use the one liner wherever you don't need the reference to the objects before. Okay, so hope that is completely clear to you why object references will be required when referring to the methods of the same class. Okay, now next thing is about this constructor itself. Like in the first example, I showed you about overloading, right? So let's come back to the concept of overloading. See, constructor is also what? It's just a method. So any method that you have can be overloaded. A constructor can be overloaded. Normal methods can be overloaded. Even the main method can be overloaded. So one of an interview question can be whether a main method can be overloaded or not. Yes, main methods can also be overloaded. Constructors can be overloaded. But when it comes to main method, only this standard signature will act as an entry point of a program. Others will not be acting as a entry point of a program. So now let us try and create the constructor, or what I mean is, let's try and overload the constructor and see how things work there. So like I overloaded a init method in the previous example, here also I'm gonna overload a demo.java, which is a constructor. So here I will give it as an age, and then I'll call it as age var, comma string name var. Okay, so let's save it, and then whichever one you call, see for this one default constructor will be called, the default values will be called. So let us call the display method and see that. So one display method will be called with the default constructor, another display method I am calling. So I want to call it with one integer argument, one string argument. So you can see that here. So one integer argument here, what I will give is, I'll give once again 45, and then I'll give it as Rohit. So these are so here I'm basically creating two objects, and on both the objects I'm calling display methods. So display method for this is called on a default constructor. So because it is a default constructor, these values has to be initialized, and the second display is called on this particular constructor, which has to take the values from the user and initialize the same value that is given by the user. So let's save it and run this piece of code, and now see two different results for the same object. You can see it is an object of the same class itself, but two different results we are getting. So different results of the same object. What is it? Polymorphism, many forms of the same object. So overloading again is a part of polymorphism itself. It is a dynamic polymorphism, happens during the class itself. It happens within the class. So compile time polymorphism, it is in the same class it is happening, right? So I hope the concept of this overloading of the constructor is also pretty much clear to you. How can we overload the constructor and how the same class object behaves differently? Okay. And also I hope now you have got to know the concept of one-liners. So demo 7, this will be an overloading of constructor. Constructors can easily be overloaded. Now one important point about constructor overloading I will show you, and while overloading the constructor, this is something which I am taking here, right? Int age var and name var. So I hope you got to know what is this method is exactly doing here. So what it does is, whatever age and name var you provide in here, that is 45 and Rohit, so it will take those values and initialize it into your name and age. So that is what is happening here. So meanwhile, what I will do is, first I will clean up everything that I have written here. Okay, and then one important point I will share with you, and then we will go back to the traditional way of creating and initializing the constructors. So here I have a variable called as age, and then I have a variable called as name, and then I am creating a void test method, or let's call it as void ABC method or something. I generally tend to give dummy names to the functions, but ensure that whenever you are creating applications, you give meaningful names to it. Why I give the dummy names is because my work is just to make you understand the concepts of Java, but your work will be to you will be working in a team, right? So your work will be to give a meaningful name to it, because based on the functionality what it does. So I have created an ABC method, then I am creating a void again display method. And then what I am trying to do is, I will be creating another variable here called as age, which is equal to 50 here, and I am creating an age variable which is equal to 100. Now you notice that I have created two variables with the same name. First of all, if I try to create a variable here, it cannot be created, right? So we cannot have duplicate variables being created. Now if I put my cursor on this, you see that the error says duplicate field demo.java age. So variables with the same name cannot be created, but I have created a variable here, right? So what is this now? This means I have created two variables with the same name, but the scope of the variable is different. Here it is an instance variable, right? It is an instance variable, and this is a local variable created inside a method, right? So this is possible. We can have a local variable and instance variable with the same name. In fact, most of the time we create the variables like that only. So let's save it and now understand the concepts of local variables. So now if I do a system.out.println here and system.out.println here, so if I do a system.out.println here and print age, there is no problem here, right? So let's create the object and call the function. So demo class d equals to new. Is it a demo class or demo Java, right? It's demo Java. T is equal to new demo Java. So I'm calling d dot the ABC method, and then I'll call the d dot display method. So let's put all those things that we have learned before. As for now, I'm not printing anything here. So in display method, I'm printing an age. So we know that this is a local variable. Age with 50 is a local variable. Local variables does not travel outside the functions where they are created, right? So here there's only one chance that the age 100 will be printed here. So let's first test that. I'll save it and run this. So age 100 is printed. Now here there is no problem because it goes to the instance variable and takes the instance variable and prints the instance variable for you, because there's no local variable here, and the local variable age is created here with 50, and that 50 value cannot travel outside this particular function ABC, right? But the problem comes up here when I try and print age. So what will be the output of this age, whether it is going to print me 50 or it is going to print me 100, because this way this function ABC can print both. It can either print 50 or it can print 100 because it has the access to instance variable. Instance variables can travel to any of the function. Also it has the access to the local variable because the local variable is created inside this ABC, so it can be accessed here. Let us first see which one it is going to call by default itself. Okay, so let's save it and run it and check which one it calls. So you can notice it is calling 50, which means it is giving the priority to local variable. First let me give you this, the concept about the local variable. Demo 8, same name for local and instance variable. So I'm giving the same name for the local variable and for the instance variable. Now comes the problem, that is I want to print 100 here. Now how do we generally refer to an instance variable? We know that we refer to an instance variable by using this system.out.println. So I can say d.age. So if I write d.age, then obviously I'm referring to an instance variable. So what is d.age? It is 100. Okay, so to call an instance variable we use the instance, correct? Instance variable. So if we give an object reference, then an instance variable itself will be called. You can see that instance variable 100. So only 100 is being called. 50 cannot be called. Why is that? That is because it's a local variable. We cannot call it there. So how am I going to call an instance variable here? So what if I try and do a system.out.println d1.age, but if I do a d1.age here or d.age here, you notice that this d that I have created inside the main method, it is local to this main method only, right? It is local for this. So I cannot do that. So that's why Java tells you that if you want to get the object of a, if you want to access the current instance, there is a keyword available in Java, that is the this keyword. So if you refer to the this keyword, it is same as what? Same as writing this. Okay, to refer to an instance variable, we use the instance name, and this will give an error because d is local to main. Okay, that's why this keyword will be used, and this keyword refers to the current class object, and this is used to resolve the conflict between the local and the instance variable. Now you see, if I just print system.out.println age, let's call it a just age, and let's call it call this as this dot age. So a just age, simple age will call a local variable, that is 50. This dot age will call 100, which is an instance variable. So you can see that just age is calling 50, the local variable, and this dot age is calling 100, which is the instance variable. So I hope you have now got to know the use of this keyword. This keyword is used to refer to a object of the current class. Okay, so let me copy this and put this into the repository demo 8, this keyword. All right. So now this keyword is used to resolve the conflict between the instance variable and the local variable. This keyword refers to the object of a current class. So you need to remember these two very important points about this keyword. Now you might also ask me a question, if this keyword is referring to the object of the current class, why do we create the object like this here? Why not just use this keyword, right? Very valid question. So let us try this keyword inside a static method. Main is a static method, right? So if I try and write this keyword inside a static method, it is not allowed here. So if I put my cursor, you can see that cannot use this in the static context. because this keyword is referring to the object of current class, whereas static comes before the object. So that is why you cannot use this keyword inside a static method. So that is a very important point. Again, this keyword cannot be called inside a static function. So I'll copy this and put this as again point to be noted. This keyword cannot be called inside a static context. Cannot use this keyword in static blocks or static functions, you can say. So I'll save it, copy and give you this demo 9. Cannot use this in static. So now let's have a quick recap of the things that we have learned. We have learned about the concept of overloading. That is, if a function performs closely related task, we give the same name to the function but with a different function signature. Then we have seen about the constructors. Constructors are nothing but what? A method, a special method return without any return type, and it has the same name as the class name. It is used to initialize the data members of a class and used to create the objects of a class. Like functions can be overloaded, even the constructors can be overloaded. So if the constructors are overloaded, we tend to create the objects in different way. Object of the same class can be created in different ways if we overload a constructor. And we have also seen the use of this keyword. All right. So let's now overload a constructor and also use this keyword in that. So if you see my previous examples, like this overloading of a constructor, where I was creating a constructor and then I call the constructor and then call these functions and everything. So at that time here I'm writing something like int age var and name var. So this is something which I want to avoid now. So what is the best way of doing this? So let's understand that best way of doing these things. So I'll go here, clean up everything, and I'll bring back my old code. So what am I going to replace in this? So I don't need to give this as age var and I don't need to give this as name var. I can simply call it as age and simply call it as name. So if I write age and name, then there is a problem. That is because I want to initialize this. I want to take the value of this local variable and initialize it to the instance variable. So what I have to do is I have to write a this dot age and then I have to write a this dot name. So in most of the demos you see on the internet, you might see things like this, right? So what is it? It is nothing but take the local variable and initialize it to the instance variable, because it is the instance variable that will be accessed inside the other methods. Okay, so taking the value from the local variable and initializing it to other variables. So now again we have two objects created. The first object is calling the default constructor, so that means the first display method should print us this. Second object is calling the constructor with two arguments, that is 45 and Rohit. So second object calls this constructor and the display method on that constructor should initialize the age and the name to the age and the name given here, so which is 45 and Rohit. So let's save it and run this piece of code, right? So I am not writing different names to it, I am writing same name so that I can avoid the naming conflicts. So let's copy this and let me put this into the repository, and this is the actual standard of doing it in Java. This is what we follow. This is demo 10 and you see how much we follow this. Demo 10, overloading constructor with this keyword. Okay, so every Java programmer does this, every Java programmer follows this. Now how can I tell you that? See, if you create a class, all of these things I have created, I'll just keep a display method as it is, rest all things, yeah. See, for constructors it is such a standard that your ID itself gives you that option. So I can right click, I can go for the source and I can generate the constructor. So you can see that there is constructor using field and then the default constructor can also be created. So what I will do is I'll just create a constructor using field generated, right? So it is same as what I created before, right? So I can even create a default constructor, just hit a control space, you get the default constructor. Whatever you want to do in a default constructor, you can do that. So I just wanted to initialize age as 19 and then name as Virat. So this is what I wanted to do, right? So this way we can create constructors, we can overload the constructor, and this is actually a standard. Now you might be thinking, what is this super? So we will talk about what is this super. It's just a parent class constructor that is being called. As for now, we will not focus on that. When we go to inheritance and everything, there we will talk about what is that super keyword which was added there. So I can save it and run it. So this is a standard. So how do you generate the constructors? You just right click it, go to the source and generate the constructor using fields. Hope this is completely clear to you. How do you generate the constructors and everything? So let me save it, and also the same thing I've already posted into the repository, so we don't need to post it once again. Now let's focus on the set of rules of overloading of either a constructor or any of the method, so that you also understand the concept of overloading in details. So I'll clean up everything that I have written here. I'll write just a simple method that is void add. So just an add method here that adds up to integer argument int a comma int b. So what is required for overloading? What is overloading now? Overloading means if functions perform closely related task, we give it the same name. Okay. But there are certain rules that we have to follow while naming the function same. What is that? So ensure number comma type or sequence of arguments is different. So any one should be different. So you can see that I'm creating an add method here with 2 integer arguments. I can create an add method that takes 3 integer arguments. This way. And see, return type, if this is void and this is int, does not make any difference. So if it is int, I have to perform a return statement, right? So return maybe a plus b plus z is what I want to do. And see, if I change the return type of a method and then give the same argument, same type of same number, type and sequence of argument, you get an error, because this is a duplicate method added int comma int. So return type is not a concern while you are overloading a method. Return type can be same or different. So return type is not a concern at all. So you don't consider a return type while overloading a method. Now here the number of arguments are different. Here the type of argument is different. Similarly, what I can do is, sorry, here the number of arguments are different in both the things. Now I will create one more method where I will create a different type of arguments, like I'll create a float a and float b. This is also valid because there is an add method that takes 2 integer argument, there is an add method that takes 2 float argument. Similarly, one more is again valid here. If suppose I write something like this, a float a and int b, this is also a valid function, float comma int. So let me just write what all it has. System.out.println. If this method has to be called, it should be an int comma int method, and if this method is being called, it has to be 3 integer int comma int, 3 integer values you have to pass. And if you want to call this method, then you have to pass in the float comma float arguments. And if you're calling this particular function, then you have to call float comma int argument, float comma int. And same way, what we can have is, we can have another method with 2 arguments only, but here what I'm changing is I'm changing the sequence. So number, type, sequence, everything I have changed now. Int b, float a. So you can notice that in the first 2, the number of arguments are different. First method takes 2 integer arguments, second takes 3 integer arguments. So the number of arguments are different. So valid overloading. Function name is add for both. Then again add method. Here what is different? The type of arguments is different. Here also we have 2 integer argument. Here also here also we have 2 arguments. Here also we have 2 arguments. But here it is of type int. Here it is of type float. Now the next method also has two arguments, but here it is float float, int int, but this is float comma int. And there is next method that is created which also takes a int and float, but int is first, then float is second. The sequence of arguments are different. So either the number or the type or the sequence of the method argument, sorry, not the method, either the number, type or sequence of argument should be different, and as long as you can give that different, you can keep creating your overloads of the methods. So I hope that the rules about the overloading is completely clear to you. Return type is not a concern. Return type can be same or can be different, but the number of argument, type of argument and sequence of argument must be different. Any one of them must be different. So this is my demo 11, overloading again. Overloading rules. So I'll put this, like I said you before, even the main method can be overloaded. So let's try to call these functions. How are we going to call these functions is my concern now. So I'll create the object of this class, new demo.java. I can directly call it like this, add. Okay, so I'll call add and I'm passing in 10 comma 20. So if you notice that I'm passing in two integer arguments. So when I pass in two integer argument, it checks whether we have a int comma int function or not. So we have an int comma int. So this function will be called. So it will print me int comma int. So let's save it and we get int comma int. Similarly, if we want to call a float function, then we know that we have to provide in an f there. So it will call float comma float. So we have a float comma float that will be called. Similarly, do we have a float and int? Yes, we have a float and int. So this will call a float and int. Okay. Likewise, if we want to call int comma float, even that is possible. So int and float this way, and then three integer argument function also we have. So we can call that as well. So whatever arguments we pass in here, based on those arguments itself, the function will be called. Second one will call int comma int comma int. The last one will call int comma float. So you can see that here. The last one is float comma int. I have not written it properly, so that's why it is telling me that. So it is int comma float. So let's save it and you see the result. Int comma float, float comma int, and then float float, and then I'm going in this order. Okay, int comma int comma int. So here it is, then int comma int. This way you can call any of the function of your choice based on the arguments that you pass. Okay, hope that is clear to you. Now what if I write something like this? I have a function here where I create something like char comma char. Okay, two character arguments. I write char comma char, and now you notice I'm removing this int comma int method here. Okay, I'm removing an int comma int method. So when I remove this int comma int method and I'm trying to pass in the arguments, let's call it as, yeah, okay. So I'm trying to pass in an integer argument and expecting that to be converted into char. Not happen, right? So it says that it does not find any. The method add float comma float is ambiguous for the type demo.java, right? So in this case, what is happening is it can call this float comma float method also. Right, and this method is not there. So now I'm trying to call it. So it says the method add float comma int is ambiguous. So that means whenever you write an integer argument, it can consider it as float on its own, right? So trying to convert that. So what I will do first is let this be as it is, whatever I created before. So let's not have this char function. Let's remove that and then try and do this. A and B, and remove all the functions first. I just wanted to tell you that this concept Oh, int comma int I have removed, so it should be an int comma int here. So just wanted to tell you that even the arguments can be typecasted automatically. Implicit typecasting can even happen when you have the arguments of a function. Okay, now you can see that I have created an int comma int function, but I am passing what? Char comma char. So this is completely valid because automatically this char gets converted into an int. So that is what you have to also consider, because in some cases what they will do is they will try and trick you in such questions in OCJP. Okay, you should remember this, that even the argument types can be auto converted, because character can easily be converted into int, right? So because characters can be automatically converted into int, this is a valid code. And even in overloading that can happen. Demo 13 or 14, type conversion of arguments. Done. All right, so one last thing about the overloading of methods. Yeah, as also I told you that main method can also be overloaded, right? So I can write a main method without arguments here. Okay, main method with argument. So system.out.println actual main, or you can call it as entry point main, and this will be simple main method. Okay, main method can be overloaded, but this method is not considered as a main method. Only this method will be considered as a main method. You can see if I run this, the main entry point itself is called, this method is not called. So if you want to call this method, then you have to call it like this, main, without any argument. So now that method will be called. So main can be overloaded, different overloads you can pass, like a main with a string argument. So again the rule is same, as long as you can change the number type and sequence of argument, simple main str, they can keep overloading the main method as well, but the entry point will be the first one, that is with the standard signature, overloading the main method. So demo 14, overloading main. Okay, one last thing about the concept of overloading and we'll be done with this. So I'll clean up everything that I have written here. One example I showed you before, that was about the add method, right? So void, or let's say int add, and in that int add I was writing an int comma int, right? Int a, int b. So this is to add two numbers, right? What if I want to add three numbers, or maybe I want to add four numbers, or maybe I want to add five numbers? Because in a calculator at times a user adds one number or two numbers, three numbers, four numbers, 10 numbers, 100 numbers, 200 numbers. So what should we do in such cases? Sometimes what we do is we don't know the number of arguments that will be provided by the user, right? So because of which Java created a concept, Java brought in a concept called as the variable arguments. So here if I write a variable argument, this is the syntax, int dot dot dot, this variable name, it can be anything. So let me just call it as 0. So as for now I'm returning 0. An integer value needs to be written. So now what is this? So this is a variable arguments in Java. What do we mean by variable arguments? A function created with a variable argument can be called with any number of arguments. Okay, so let me just call it as new demo.java, and d.add. Suppose if I am calling an add now, so I can call the add with one integer argument. So let's just print a line so that we know that it is being called, system.out.println add method. So let me save and run it and see what is the result. So we got the add method by passing in one integer argument. So let me pass in two integer arguments and see what happens, and then let me also pass in three integer argument and then see what happens. Okay, So I have created only one add method, but I can call it in different ways. This is what variable arguments is all about. But you should ensure that the type of this argument is same. That's because internally it is an array. Internally it is an array. How can I say that internally it is an array? We know that arrays have what? Index positions. So I can say a of 0. Okay, so initially a of 0 here will be what? 10. Here a of 0 10. In third one also a of 0 will be 10. Let's write it as 50 here, and then here we will write it as 33. So let's save it and let's get the elements. So you can see that a of 0 10 in the first case for first method, for second method a of 0 is 33, for third method a of 0 is 50. So this proves you that it is an array internally. This is the syntax for variable argument. You can give any number of arguments and call the function variable arguments. Next important point about the variable argument is that variable argument, Varargs is what we call it as. Varargs must be the last argument in an argument list. That means there can be only one variable argument. There cannot be two variable arguments like comma int b, int dot 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 b. It's not possible to write it like this. That's because variable argument must be the last argument in a argument list. You can notice that here. The variable argument type int of the method add must be the last parameter. So it cannot be created as a first argument. Even I cannot do this int b. It's not possible. So, but this is possible. I can do something like this. Int b, comma. So in this case, what happens is this 10 will go into the b, and then rest all values go into the a. Okay, so let's check that. Now that in the first argument a of 0 is not there, right? So when we run it, it says array index out of bound exception because a of 0 is not there. This 10 value is going to b, right? So because of which the first one is not getting executed. The others will get executed because whenever an exception occurs, program gets terminated. So now you'll see in the first one 88 is something that is given to a of 0. In the rest all cases this is going to be 33, 50 is going to be, and rest all is part of a itself. So you can have variable arguments with different arguments, not just int, it can even be string. So if it is string, then what you have to do is you have to pass in the first argument as a string. Rest all arguments will go to a. Okay, so you can have variable arguments with a different type of arguments, but you should ensure that vararg is the last argument in a argument list. Okay, so I'll pass this. I've already given you overloading main. I have not given you a variable argument, right? So I hope by this code you should be understanding what exactly a variable argument is. So this is demo 15, Varargs. Now let me give you one simple use of variable argument in real time, and we will finish off with this particular session. So I'll remove this string b or something from here, and I'll just have an add. I'll just take a, then let's remove this from here, and what I will do is I'll create the variable sum is equal to, first of all I'll give sum as 0, which I'll create here, int sum is equal to 0 as an instance variable because I don't want the value to be initialized again and again. So whenever a function is called, it should be here. Then sum is equal to sum plus a of 0. Okay, and just return the sum of it. So let's save it and let's go here, d dot add. Now I'm giving 10 plus 20 plus 10, so that should be 40, right? So let's save it, and we'll do a system.out.println. And one more thing here, we can take a variable and print it in system.out.println, or we can directly call the functions inside system.out.println. That is another new thing that I have added into this session. So run it. So it says just 10, that is because sum is equal to, sum is equal to sum plus a of 0 obviously will be 10. So what I have to do is I have to loop through with this. So for int x colon a, and then sum is equal to sum plus x. Okay, an enhanced for loop I'm using, and then the sum will be returned. Now what I can do is I can initialize this sum to 0 here itself. So let's save it, run it now, and you can see that it is 40. Similarly, what I will do is I'll call it once again with maybe some more argument, 40 plus 60, that is 100, plus 50, 150. So second result I'm expecting it to be 150. Let's run it and you can see it is 150. So this way we can make use of the variable arguments, and we have created a add method in such a way that now a user can add up any number of numbers that he wish, right? So it was 150 plus 20, 170 plus 10, 180 plus 20, 200, right? So many numbers I am providing, and my method adds up all the data. Okay, 200. So this can be just a way how in real time this type of variable argument functions can be used. Variable arguments in real time. So kind of interview questions or maybe OCJP questions which will be asked into variable argument is that variable argument, you should note one important point, that is variable argument must be the last argument in a argument list. That is an important point you need to remember about the variable arguments. So they might give you two variable argument and ask you whether it is valid or not. They might add another argument here after this, a normal argument, and then ask you whether that is valid or not. Okay, and they might even try to get the array index positions and then try to ask you at this position what will be the value of it, because internally this variable argument is nothing but an array itself. So I hope you're enjoying this series, and you continue to follow this series, and also don't forget to practice the questions that I have shared already into the repository. And if you're liking in the series and you want more such videos, do share these type of videos and comment on the videos so that it encourages me to create more such content for you. So have a nice day. See you in the next video.